this is our second class on the population genetics. In this class, we will discuss more questions related to the Hardy-Wimber equations. So let's begin. So as we have already seen in our previous class, suppose this is the homologous chromosome, and you are having one gene present on the particular locus, um, which describing a particular characteristic. So it is either can be dominant or recessive trait. So this is the two alternative form of the allele of particular gene. Okay, so these three where this alleles is present is called as the genetic loci, and this capital B representing the dominant allele or dominant form of that particular gene, and this small allele is representing the recessive character of that particular gene. Okay, so suppose in both the locus, if the gene is present as its dominant form, then it is called as the homozygous dominant. If it is present as a both the loci, if it is present as a recessive form, then it is called as the homozygous recessive. And if it is present in one loci as a dominant form and another loci it is a recessive form, then it is called as the heterozygous. Okay, so there is three type of probability. One is homozygous dominant, one is homozygous recessive, and another one is the homozygous recessive. Okay, so regarding this, Hardy-Wimber suggests that if the population is in equilibrium, or in the genetic equilibrium, then the genetic then the P plus Q equal to 1. Means they give two kind of equation. One is the P plus Q equal to 1, where P is the your uh, dominant allele and Q is the your recessive allele. Okay, here it is the recessive allele and P is the dominant allele. This should be equal to the 1. Okay, because in your gene is present in the diploid organism, so it is having two allele. Either it can be A, okay, or it can be small a. Okay, so it is represented by the small p and small q. Okay, this is the dominant one represented by the small p, and this recessive is represented by the small q. This should be equal to the 1. Okay, but you are having two alleles. Okay, this is the single allele we are talking about, but you are having the two alleles. Okay, a or small a. So in that case, you are like when you are crossing such thing, okay, in genetic scenario, so you are having 2p square and 2q square for homozygous dominant and homozygous recessive, and this pq is representing the heterozygous form of the gene. Okay, heterozygous form of the gene. Okay, so the frequency of allele A is represented by p, small p. The frequency of small a is represented by the small q. Okay, so here it is the genotypic, it is considering as a genotypic frequency. Okay, this is the genotype frequency. Okay, because here you are considering both the alleles, and this is the allelic frequency. because here you are talking about single allele. Okay, this is the allelic frequency and this is the genotype frequency. Okay, so that is only elaborated here. The frequency of genotype is A is represented by P square. The frequency of genotype small a is represented by Q square, and the frequency of genotype capital A small a is represented by 2pq. Okay, because when you cross these two a, okay, that time you are getting two you are getting this kind of phenomena, this kind of offspring. Okay, okay, so this is 1, this is 2, and this is 1. Okay, that's why it is p square, this is 2pq, and this is again q square. Okay, because here 2 into p is represented by this capital A and q is represented by this small a. Okay, so yeah, that is the thing. Then to calculate the allelic frequency, you have another formula. In any population where n is the total number of individual in the population, suppose in the question you know the total number of individual in the population, and you know the heterozygous number, then you can use this formula to find out the frequency of dominant allele as well as the recessive allele. Okay, so what is the formula? That is the 2 into total number of homozygous plus total number of the heterozygous divided by 2 into total number of the population. Okay, like that, if you want to calculate for recessive one, this is 2 into total number of recessive population plus total number of heterozygous, and this is the total number of population. Okay, so this is the dominant, this is for dominant allele, this is for dominant allelic frequency, and this is for recessive allele frequency. Okay, so this formula you also have to remember. There are two formulas. First one, if you want to calculate the allelic frequency, there are two formulas. First one is the p plus q should be always 1. Okay, and the another formula is when you know the population size and the heterozygous population, then you can use this formula frequency of to calculate the dominant allelic frequency as well as the recessive allele frequency. So the dominant allele frequency, if you want to calculate, then it means 2 into total number of dominant homozygous plus total number of heterozygous divided by 2 into total number of population size, like that for recessive allele. Okay, so moving to our first question, that is the consider a population of 10,000 individual, of which 2,500 are homozygous and 3,000 are the heterozygous genotype. Then the frequency of allele P in the population is. Okay, so here in the population it is saying you are having this homozygous population as well as the heterozygous population. Okay, and you know the population size also. Okay, total population size. So as I earlier told you, like if you are having these three information, you can use this formula. Okay, so to using this formula, so to using this formula, what you have to do is you firstly you have to identify this allelic frequency of dominant P. Okay, this P you have to identify first. Okay, so allelic frequency of capital A. Okay, allelic frequency of capital A equal to in the for as per the formula, 2 into total number of dominant allele number. Okay, that is the 2500. Okay, plus number of heterozygous. Number of heterozygous is here is 3000. Okay, then divided by 2 into total number of population. So total number of population is how much? 10,000. Okay, so what will be the, when you calculate, is this is 2 into 2500 will be 5000. Okay, plus 3000, then divided by 20,000. Okay, then it will come 8,000 divided by 20,000. Okay, this 30 will cut down with this 30 and it will give you a 0.4. Okay, so capital A or P equal to, you got, okay, for single allele it is 0.4. Okay, now you want to calculate the allelic frequency for small p. Okay, so for a small p, as we know that p plus q, okay, equal to 1. Okay, so here you know that p equal to 0.4 plus q equal to 1. Okay, so here it will give q equal to 1 minus 0.4. Okay, so it will give q equal to 0.6. Okay, so this is the answer. Okay, 0.6 is the answer for allelic frequency of small p. Okay, so what I told you is, if you are having these three information, like if you know the total population size, then you are having the heterozygous population size, then you should use this allelic frequency formula. Okay, so for that you have to firstly identify the one allele frequency, either it is if it is asked for the recessive allele, firstly identify the allelic frequency for dominant allele. Okay, so here it is asking about the recessive allele, so that's why we firstly identify the dominant allele, that is the 2 into 2500. Okay, according to the formula, 2 into number of total number of the homozygous dominant plus number of heterozygous, okay, divided by 2 into total population size. It will give you the 5000 plus 3000. Okay, then divided by 20,000 equal to 8,000 divided by 20,000, it will give 0.4. So p you got 0.4. Okay, so as you all know that from other formula, p plus q should be 1. Okay, so here if you put the value 0.4 plus q equal to 1, then q equal to 1 minus 0.4, so q equal to 0.6 will be your correct answer. Okay, so here the answer will come 0.6. Okay.